reason we need our sum and difference identities is because of the first question here. In order to do a first question like this, what most people want to do is say, oh, well, doesn't the cosine just distribute to both of these? Well, that's what you're seeing on the right-hand side, as if I distributed. It's an easy question to see, does this work? Because if I look at the left-hand side, order of operations would say I would do what first? Add those first, which would give me cosine of what? 90 degrees. From our unit circle, we know what the cosine at 90 is. We know the cosine at 90 is 0. Not 1, excuse me. On the other side, if I had distributed, we know the cosine of 30 degrees is root 3 over 2. We know the cosine at 60 degrees is 1/2. If I add those together, is that going to give me 0?
Yes.
Alex? No. So, in this case, they're not going to be equal. You may not distribute a cosine. It doesn't work like that mathematically. Okay? So basically what our sum and difference formulas are saying, since you can't take this and distribute your sine and actually have it work out to be equal, this is basically the long form of the distribution if you needed to separate them into pieces. There's a whole proof for it. Most of us don't want to see that because there's one for every single one of these. Alex, I know you would love to, and you can come in and see me for that. Okay? I'd love to show you proofs. I'm sure that'll be very exciting. Okay? So basically these formulas are the long form of the distributions for these. They've given them to you so that you don't have to figure it out yourself. All you're really doing in here is plugging in and going back and forth. So what happens then in a question like number 2, they give me this long, complicated version of something here, and they would like me to simplify this. All you're doing here is basically playing matching and seeing, okay, I've got 4 formulas here. 1, 2, 3, 4. Which one does number 2 look the most like?
2.
No. Nope. Be very careful with this. Signs matter. Okay? And it matters which one, so I look at 2 different things. First thing I look for is the plus sign. That eliminates 2 of them for me right here. Okay, because they have minus signs in them. Second thing I look for, notice in the first one your sines and cosines are split up. In the fourth one, your cosines and sines are together. Which one are we looking at then?
Last one.
The last one. This is like number 4. Okay? Because my cosines are together, my sines are together, and they have a plus sign in the middle. So, like I said, it's just playing matching. Right now, they've given me something that looks like the right-hand side. I can turn it into the left-hand side because they've told me that those are equal. So a lot of people are like, well, where did all these things disappear to? Well, they disappeared because they told me they disappear. That's the only reason. They've told me these 2 things are equal, accept it at face value, and move on. Okay? All you need to know in order to simplify this in number 2 is that according to this formula here, this would be my A value and this would be my B value here. So my A is 3x and my B is 2x. I'm just literally lining that up with what's here and what's here. So according to my formula on the left-hand side, this simplifies to the cosine of A minus B. Well, what did we say my A was? 3x. Minus, what did we say my B was? 2x. That's a heck of a lot simpler. And I can actually subtract those and just get cosine of what? X. So all of this, just because they gave me those formulas are equal, simplifies down to cosine x. Much simpler version. Okay? So right now we're just practicing simplifying with this. The real reason we use these is for questions like number 3. 3 is kind of the whole point of this. If I look at 3, okay, and let's just say this is a non-calculator section. Okay? I have no calculator to use this. I have my brain and my unit circle. Do I know anything about the sine of 105?
Yes.
Not much, right? 105 is not in my unit circle. Can't tell you anything about it. I know nothing about the cosine of 15 either because 15 isn't in our unit circle either. Okay, so right now we'd be at a standstill. I have nothing that I can do with this. Well, according to these formulas, I can make this a simpler version. So again, let's play matching. We've got version 1, 2, 3, 4 up here. Being careful with our minus signs and our mixed sines and cosines. Which one does this look the most like? 2. Okay, looks like 2, and if it looks like 2, what's my A and what's my B? 105, and my B is Okay? According to this formula, I can take all of this stuff and make it a whole lot simpler using the left-hand side. So if I just use the left-hand side, all of that collapses down to sine of a minus b. Well, if I'm using that formula and I do a minus b, that's going to be what minus what? 105 minus 15. Well, what does that do for us? That simplifies to sine of what? 90. I know what that is. Sine at 90 is just 1. So without using a calculator, without having to find out anything about 105 and 15 degrees, I can take that all, collapse it down to something I can find. That is not on this quiz. It will be on our final quiz when we get back from spring break. But we'll review before that because I'm not crazy in the head. Okay? All right, so we're going to practice this on the left hand or on the back side of the page here. Okay? On the back side, you can also use these formulas to do proofs. Okay? We did a proof on our quiz last one. Most of us did better at the proofs than we did at the shorter ones. But if you remember proofs, we remember our setup for proofs. What is the setup for proofs? Left-hand side to right-hand side. So if nothing else on this, you set that up. Set up left-hand side to right-hand side. That is our goal. Now, this one did not give me a very complicated long string of things. It's instead given me something that looks like those left-hand side formulas. Okay? So, if I'm looking at this, again, I'm asking myself which of our formulas it looks like. I'm not going to flip back a page, and if you have your formula sheet, you can get that out. This is a cosine formula where you are adding or subtracting two things. Adding. Okay? And you don't have to show this out to the side. I'm just going to show this work out so that you know what I'm looking at, like if I was looking on a formula sheet. On my yellow formula sheet, I have a formula that says cosine of alpha plus beta, that's just like a plus b, is equal to, what does it say on the formula sheet for you? Cosine alpha, cosine beta, minus sine alpha, sine beta. So that's literally just copying off my formula sheet. I just looked for the cosine formula where two things are added together. Beta is the same thing as B, and alpha is the same thing as A. It's just different notation. So, according to that formula, if I'm using that, what right here would be my alpha and my beta? Pi would be alpha, because that's the first thing. And what? X would be beta. So according to this formula, I can take something that looks like this left-hand side, and I can make it a whole lot bigger using the right-hand side. For a minute, it's going to look terrible, and then it's going to simplify. So if I plug those things in using pi as my alpha and x as my beta, what's it going to look like? Cosine pi, cosine x, minus sine pi, sine x. So I just took this formula over here, and anywhere I saw an alpha, I plugged in pi. Anywhere I saw a beta, I plugged in x. Well, what does that do for us? Do I know anything about cosine of pi? That separated this into things that I actually know something about. The cosine value at pi, I know from my unit circle to be -1. So I keep that in place of cosine pi, and I keep that next to the cosine x that was already there. Then I continue to the next thing. Do I know anything about sine at pi? Yes, I do. What is the sine at pi? 0. I keep that, and I multiply by the sine x that was there. Well, we also know something about when I multiply something by 0, what happens? It disappears. So what is left in that formula? -1 times cosine x, which just gives me negative cosine x. So by splitting it into pieces that are manageable, I can work it down to something that's a lot simpler. So all we did was take our alpha and our beta, plug them in, simplify what you know. Okay? Anytime it says verify the following identity, it means write a proof like that. So your proof is just showing your work. The main other question that we're going to do with these is what we're doing in question 5. Question 5 is a throwback to chapter 6 where we drew triangles, labeled sides of them. This is where people tend to get confused on these. So this will kind of be the big concept for the rest of the class. Okay? So if you move down then to question 5. They've given me information in question 5 about 2 different angles. How do I know there's 2 different angles there? Because I have an alpha and I have a theta. So 2 different symbols. So what I do to start off with is let's just look at information all about 1. So here's all my information about alpha. First, they tell me alpha is in what quadrant? First, because they tell me 0 to 90. So draw yourself a triangle in the first quadrant, label your angle alpha. And if you remember from chapter 6, we use this other piece of information, sine is equal to 4/5, because we know sine is equal to what 2 sides of the triangle? Opposite and hypotenuse. So in that triangle, they've given me the opposite side is 4. The hypotenuse is 5. If I know my Pythagorean triples, I know my third side is what? 3. So all of that information helps me draw a picture for alpha. Then I do the same thing with theta. All right, they've given me sine of theta, and they've given me a location for theta. Theta is in what quadrant? 2, because it's 90 to 180. Okay, there's my theta. Again, size of these triangles doesn't really matter, you're just drawing them. Again, they gave me the sine, which is the opposite and hypotenuse. So opposite is 5, hypotenuse is 13. Again, if I know my Pythagorean triples, I know my third side is what? Anyone remember this one? 12? Okay. And since it's going to the left, I'm going to label it as what? Negative 12. All right, so don't forget that stuff. That's the part that threw us for a loop in chapter 6. All right, now, we see what do they want me to find with this? They want me to find sine of alpha minus theta. I have a formula that looks a lot like sine of alpha minus theta, only on my formula sheet, what does it say instead? Sine of alpha minus beta, right? That's just the same thing. It's just saying in place of this beta, replace any beta or betas that you see with theta in this case. Okay? What does my formula for a sine minus say? Sine A, cosine B, which is theta. Then what? Minus cosine alpha, sine beta, which is our theta in this case. So I'm just replacing those. Now, here's the big question. Where do we go from here? Well, according to these triangles, I can have fractions that are equal to the sines and the cosines of each of those. If I come out to the side here, I know what the sine of alpha is according to this triangle. According to that triangle, sine of alpha is equal to what? 4 over 5. What other information from that triangle do I need? I need the cosine value. The cosine value in that triangle is what? 3/5, adjacent over hypotenuse. I need that same information for the second triangle. Sine of theta, according to this triangle, is equal to what? 5 over 13. And cosine of theta is equal to what? Negative 12 over 13. Now, because I know what they're equal to, I can literally take out those values in this formula and replace them with those fractions. So in place of sine of alpha, I can put what fraction? 4/5. In place of cosine of theta, I can put what? Negative 12 over 13, and I'm going to multiply those two because they're sitting next to each other. Continuing down that long road here, I got cosine of alpha. What is cosine of alpha? 3 over 5. And times sine of theta. What's sine of theta? 5/13. These questions will most likely be on the non-calculator section where I give you a baby calculator. So remember, for fractions, when we multiply them, what parts do you multiply? the tops and the bottoms separately. So the first one, I multiply 4 times negative 12 gives me negative 48. 5 times 13 gives me 65. Second fractions, 5 times 3 is going to give me 15. 5 times 13 is going to give me 65. Notice I didn't cancel my 5s there. Why not? Because then I'd have to find a common denominator later, and I don't really want to do that later. By not canceling my 5s right here, I've left it as both over 65, and I can already subtract it. So if I subtract those two fractions, negative 48 minus 15 gives me what? Negative 63 over 65. That's as simple as you're going to get on these kind of questions. Notice, though, in those triangles, they were pretty nice to you on the sides. There's none of them with roots in them. It's mostly just fractions and Pythagorean triples, because really I'm worried more about the formulas and being able to do the fractions than I'm worried about the roots right now. Okay? It could get rather nasty if you did that. But, okay, so what I want you to try then real quick on this one, because notice in the question they asked me for two different things. They asked me for sine of alpha minus theta. They also asked me for what? Cosine alpha minus theta. The only difference with that is that it uses a different formula. You use the same fractions to plug in, they're just going to go in different locations. So take a minute on your own paper. Write out the formula for cosine of alpha minus theta according to your formula sheet and plug in the correct fractions. Take a minute and try that one. All right, on your tangent formulas. Shh. These are just on a different page because the tangent formulas look different. They're not like we apply them differently. Tangent formulas are really easy to recognize. They're less guessing because they only have tangents in them. The sines and the cosines ones all kind of look similar, so you got to be careful which one you pick. The tangents ones are pretty obvious. The main difference between the two of them are your plus and minus signs here that flip. So really, you just have to look at those when identifying. So the only question we're doing on this page is 1. Okay, 1 looks the most like which formula, the top one or the bottom one? Top, because it has a plus sign on top and a minus sign on bottom. If I'm using that, that means according to these formulas, what's my A value? 30. What's my B value? 15. So you're taking something that looks real complicated like this, and because your formula says it's equal to the thing on the left, you can make it a whole lot simpler by just plugging in your A and your B value on the left, which simplifies to tangent of what? 45, which we know the tangent at 45 is? 1. Because at 45, your sine and your cosine are the same, and when you divide them, it gives you 1.
So you literally don't even have to.
So you literally don't even have to worry about the rest of the formula. You're just simplifying. Okay? Real quick, we're just going to set up one more of those triangle problems on the back. But we're not going to do all of the problems with it because we've already done some. So flip to the back, and we'll be done. All right, so this is another one of those triangle problems that has your alpha and your beta. Again, you're looking for information about each of them within the problem. So if I'm starting with alpha here, the first thing they tell me about alpha is it's between pi over 2 and pi. What quadrant is that? 2. Okay, so here's my alpha. The second thing they tell me about alpha is the cosine, which gives me which two sides of my triangle? Adjacent over hypotenuse. So the adjacent is negative 3. The hypotenuse is 5, which tells me my third side is what? 4. Then I set up the exact same thing with my beta. This one tells me my beta is between pi and 3 pi over 2. What quadrant is that? Third. So if I draw that in the third, I purposely draw my triangles different sizes like this. Mostly because if you match them up, you'll forget that their sides that come together on the x-axis aren't necessarily the same length. So I purposely draw mine different sizes. They don't have to be like the correct size, but it's helpful to you if you do that. They also tell me in this tangent of beta is 12 over 5, which gives me what? Sides. Opposite and adjacent. So does it make sense in the third quadrant for the opposite side to be 12? if you're going to the left and then down, negative 12, and the adjacent side should be negative 5. And using the same Pythagorean triples, what should my hypotenuse be? 13. Good. Hypotenuse is never negative. On these, usually, like if you look at a problem like this, right now we're not going to do all 6 parts of this because we're not going to spend the time to do it. We've already done the sines and the cosines. I just want to work on the tangents. Okay? If I was doing this problem on a quiz or a test, I would take a minute and sit next to this blue triangle and say, okay, sine of beta is negative 12 over 13. Cosine of beta is negative 5 over 13. Tangent of beta is 12 over 5. If I set those up in advance, it really just makes it plugging numbers in for all 6 parts, which makes life a whole lot easier. And I would do the same thing for my alpha problem too. So I would say sine of alpha is 4/5. Cosine of alpha is negative 3/5. Tangent of alpha is negative 4/3. So if I set those up at the beginning, then all 6 problems become a whole lot easier because you're just writing out the expanded version, plugging in the correct formulas. Okay? Really doing the tangent ones are very similar to each other, so I'm just going to scratch out this A so I don't have to erase my picture, and we're going to do part E up here, which is tangent of alpha plus beta. Right? So if I look at my formula sheet, tangent of alpha plus beta, its expanded version is going to be equal to what according to my formula? Tan alpha plus tan beta over 1 minus tan alpha tan beta. After I get that piece of information, all I have to do is plug in what I know. So according to what we've written up there, what is the tangent of alpha? No. Negative 4 over 3 from the first triangle. Plus, what's tangent of beta? 12 over 5 over. It's not negative because it's a negative over a negative, which makes a positive. On the bottom of that formula, it then says 1 minus tangent of alpha, so that's negative 4/3 times tangent beta, which is 12/5. I real quick simplify that and minus a negative on the bottom. That's going to turn into a what? Positive. Okay, then the rest of this is just dealing with fractions, which I know are our favorites. So if I'm going through this one in detail with you, to add these 2 on the top, what do I have to do? Common denominator. What's the common denominator for 3? 5. So I multiply the first one by 5, second one by 3. That makes this negative 20 over 15 plus 36 over 15. On the bottom, I don't have to currently get a common denominator. I have to start by multiplying those 2 fractions. Okay, we can and fix it in a minute, yeah, but I do both at once just to simplify life. On the bottom, I'm just multiplying those 2 fractions across the top and across the bottom, which gives me 48 over 15. In order to add 1 to that, you're going to have to change 1 to what? 15 over 15, right? So now let's do the top and the bottom. Negative 20 plus 36 gives me what? 16 over 15. On the bottom, 15 plus 48 gives me 63 over 15. What do I do in a situation like this where I have 2 fractions? Okay, keep the top, flip the bottom, and multiply. What cancels? The 15s, which means my final answer is what? Okay? Chances are on a test you will have one big problem like this. I'm not going to make you do this a million times. I'm just going to set it up once. Do all that. We'll be good. Okay? Do we really need to do the tangent minus if it's just flipping your negatives?
Yes.
All right. In that case, homework for this is 2 different parts. I'll write the problems right here. Page 233, 1 through 10. And page 236, 1 through 9. You have the rest of the class to work on that. If you need to take the quiz, you have 2 options.